Okay, hello. I'll be going through this Methodist Girls P4 Weighted Assessment 3. And let's begin. So, question 1. Which of the following figures is not a symmetric figure? So when they say not symmetric means it does not have a line of symmetry. So remember, line of symmetry means a line that is drawn in the middle of the diagram such that the left side and the right side, or the top and bottom, they are like mirror image to each other. Okay, so let's see which one would that be. Okay, sorry, let me just connect my writing tablet first. Okay, so let's look at option A. Option A is a rectangle, as we all can tell. So a rectangle is a regular shape that definitely has a line of symmetry, because I can cut it this way. Definitely this will be a line of symmetry, or you can even cut it this way. Okay, so there are a few options for option A. So A is out. I want something that is not a symmetric figure. Okay, now let's look at B. B, this shape, all right, if you cut it in the middle like this, okay, be careful. This is not a symmetric figure because you notice the left side, it does not reflect exactly on the right hand side. Okay, remember mirror image. So this side is bigger, whereas on the right hand side, the top here is bigger. So in this case, your option should be option 2. Okay, we shall continue with C and D. So C is an oval shape. It's a regular oval shape. So this one definitely it has a line of symmetry. This. Okay. Option D is a circle. So circles, of course, line of symmetry for sure. Okay, so B is the answer since it does not have a line of symmetry. Okay, the next one, round 276.175 to the nearest tenth. So nearest tenth, in this case, take note, you need to look for the 10th place on the number first. So 10th place, it also means the first decimal place. So the first decimal place, where is it? It is the number right after the dot. Okay, so your 1, this is your nearest 10th. This is your 10th place that we're talking about. Now, the next thing is look at the neighbor on the right-hand side. The neighbor is 7. Okay, so we got to identify whether 7, is it a strong or a weak neighbor? Can it help the 1 to level up? All right, so 7 is a strong number. Okay, it's a strong number, so definitely this 1 will level up to become a 2. So your option should be 276.2, which is option 3. Okay. Now the next one, express 6 whole and 1 over 50 as a decimal. So this is a fraction. When we want to change a fraction to a decimal, the first thing we look out for is the denominator. See whether you have any familiar numbers that you can work with to change it to 10, 100, or 1000. So 50 is a number that you can easily change to 100. Okay, you can only go up, can't go down to 10. All right, if you go down to 10, then the top number you can't divide anymore, so it's useless. So you gotta go up to 100 instead. 50, I can easily multiply something to get 100. Okay, so I'm just gonna do my workings here. 6 whole and 1 over 50. So what do I multiply to 50 to get 100? All right, so I hope you can observe that it's actually multiplied by 2. Okay, so I multiply by 2 to the numerator and the denominator. The whole no change is still 6 wholes. Okay, so this becomes 6 whole and 2 over 100. Now, with a denominator 100, I can easily put it as a decimal already. So 6 wholes is just 6. And then you put a point. The point is the decimal point. All right. So 2 over 100 means your 2 must exist in the 100th place. The 100th place means the second decimal place. So your second decimal place will be here. Your 2 must exist here because this is the first decimal place right after dot. This is the 10th place, we can call that. The next one will be the 100th place, okay, which is your 2, that your second decimal place. So in this case, your blank here, you just fill it out with a 0. So there you go, option 1, 6.02. Question 4. Zoe wants to shade 3/4 of the stars below. How many more stars must she shade? So take note, she wants to shade 3 out of 4 of all the stars here. Okay, so if we look at the denominator, it is a 4. Okay, but if we look at the total stars here, so in this case, our denominator should represent the total stars. But of course, my total stars is way more than 4. So you need to count how many total stars are there. Once you have counted, you're going to change this denominator accordingly. Okay, so let's count. There's 1, 2, 3, 4, 5, 6, 7, 8. 8 here, 8 bottom, so it's 16 stars. 8 plus 8, right? Okay, so that means my 3 over 4, I need to be able to change the denominator to a 16. Okay, and to do that, I have to times a 4 to get to 16. Right? And do the same for the top, times 4 as well. So now you can figure out the new numerator, which is a 12 over 16. That's your new fraction. That means out of 16 stars, I need 12 to be shaded. Now, but unfortunately, I don't have 12 shaded. We can only see there's only 2 shaded. All right. So simply, you can take your 12 minus your 2 that's currently shaded to find how many more to shade. So you need to shade 10 more stars. Okay, option 3. Right. I'll go on to question 5. Okay, Mrs. Tan had 18 kg of flour. She used 2 out of 3 of it to make some cakes. How much flour did she have left? Right, so 2 out of 3 of it to make some cakes. Take note, this 2 out of 3 means I use 2 units out of 3 units. This is how you can interpret this fraction. I use 2 units out of 3 units. 2 units is used to make my cakes. 3 units is basically the total flour at first. So you can actually go on to draw a simple model to show this information. So how many units to cut first? Of course, I cut 3 units first because that is my total flour at first. So I use 2 units to make some cakes. So you can actually go on to label that down. This is for the cakes. Now let's understand where is the 18 kg on the model. 18 kg of flour. So flour means her total flour at first. So of course, your 18 kg must be this whole thing. And there you go. You should realize that 3 units is 18 kg. Okay, so 3 units is 18 kg. So of course, I can go on to work out 1 unit. Just do the division. And the question is asking how much flour did she have left? Okay, so whatever is left, basically it's this last unit that's left, right? Because 2 parts is used to make cake already, so this is the leftover. And you know this leftover is actually 1 unit, which is what we have here as our answer. So that will be option 2, 6 kg. Okay, I hope it has been fine so far. I'll move on to the next question, question 6. Arrange the following from the greatest to the smallest. Okay, so we have a mix of fractions and decimals shown here. It is, of course, very difficult to compare who is the greater one, who is the smaller one, just by looking at a mix of fractions and decimals. It doesn't really do, it's very difficult to observe. Okay, so what you can consider doing is you change your fractions to decimals if it's possible. So let's look at the fractions. This is a 52 over 100. Luckily, the denominator is already 100. So definitely it's very easy to change to decimal then, right? Easy to work with. Okay, so 52 over 100, your decimal should be a 0.52. All right, so your 52 will take up the 10th and the 100th place, basically 52. So it's 2 decimal places. Over 100 means, you should have 2 decimal places. This is how you can see. All right. Here, I shall erase my bracket because later we're going to do something to it. Okay, so sorry about that. All right. Now, the next one, 14 over 25. Now, 25, it's a very commonly used denominator, and it's very helpful also because 25, you can easily change it to 100. Okay, so take note, if you haven't do enough practices, it's okay. Once you do enough practices, you realize that 25 times something can easily change to 100. And that's actually a times 4. Okay, so this is a very useful number, commonly used as well. All right, so basically 25, I got to times 4 to that so that I can change it to 100 denominator. Right, and this should give us actually a 56 over 100. Let me just put it up here because I don't have space. So 56 over 100 if you did your calculations. So in decimal, easy. This will be 0.56. Okay, now before we now start comparing the decimals, who is bigger, who is smaller, and things like that, you should always check whether the number of decimal places are they all the same throughout. So what do I mean by number of decimal places? For example, if you look at this, there are 3 numbers behind the dots. So there are 3 decimal places for this number. Okay. However, for my 0.52, there's only 2 decimal places. So I want to make it the same as 3 decimal places so that I can later safely compare my numbers. Easier to compare also. Okay, so how to make it 3 decimal place? You have 1, 2, just need to add a 0 behind. Maybe I should use a different color. Yeah. Okay, so just add a 0 behind so that you know you need to include a 3rd decimal place, then you can easily compare with the 0.521 later. Okay, same for this 0.56. You see, there's only 2 decimal places, so simply add a 0 at the back to make it 3 decimal places. Last one is already 3 decimal place, 512 behind the dots. Okay, so now you can go on to compare the small and the big ones. All right, so they all start with a 0.5, 0.5, 0.5, 0.5. Okay, so never mind. Look at your next number, the 100 place. You should notice the 100 place throughout. This one is the smallest. Okay, the one here is the smallest, 0.512. So this guy is the smallest guy. Okay, now let's see what's the next one. Okay, after this, maybe let's look out for the greatest. So the greatest, we have a 521, we have 520, we have 560. Of course, the greatest will definitely be this one, the one with 560. Okay, so now you can go on to compare. Actually, you can go on to compare these two also, but actually, since this is MCQ, I get to choose my options, then never mind, I can save some time. So you see, if you see 0.512, it should be this one starting. Oh, sorry, no, so this is the greatest, sorry. Okay, so greatest is 0.560, which is 14 over 25. 14 over 25 is this option, greatest. And next, you check whether you got this right, 0.521, and then this is 0.520. Okay, so it's correct lah, 521 and 520, decreasing order. And the last one, smallest, is your 0.512. There you go, you have your option 4. Okay, now let's look at question 7. Find the value of 10.3 minus 0.99. Okay, so we are going to do the subtraction. Now, when you do subtraction for decimals, you have to make sure, sorry, additional 3, you have to make sure that the dots, the decimal point dots are aligned together. So you see 10.3 minus 0.99, your 0.99. Okay, so this is how it looks like. 3 is above the 9. Now, there's a gap here, right, above the 9. Okay, so what you're going to do is you are just going to fill that gap out with a 0. So technically 10.3 is the same as 10.30. Same over here. 0.52, I can also say 0.520. They are the same thing actually. The 0 at the back does not have an impact for numbers with decimals. For whole numbers, of course, it changes the value, but for decimals, this 0 at the back, no, it doesn't change anything actually. Okay, so make sure you have consistent number of decimal places before you subtract. 2 decimal place, 2 decimal place. Then you can go on to perform your subtraction. Right? So we're going to subtract for this. Okay, I'll just use a different color. Let's use a orange one. Okay, so let's subtract. 0 come minus 9, so 3 cancel, become 2. Then this will become a 10. I'll just put a 1 next to the 0. Okay, I hope you all can see that. All right, so this becomes 10 minus 9, which is 1. 2 cannot minus 9, so 2 you can take away from the 10 here. You can just take away from this whole thing, which is a 9. And then put a 1 next to the 2. Okay, so it's 12 minus 9 now, which is 3. Yeah, I should write this properly. Yeah. Okay, so it's 10. All right. Okay, then the next one is a 9 minus 0, so it's a 9.31. Okay, sorry, I actually wanted to use a blue pen for this. All right, so this is a 1, 3, 9. Okay, 9.31. That would be our answer for this question. All right. Okay, the next one, find the value of 5.32 times 7. Okay, I'm going to space out my numbers. So when you do your workings, try to space out your numbers, yeah, so that you got space to do your, whatever you need to do. Okay, so let's start with the 2 times 7. 2 times 7 is 14. So when you times 7, yes, 7 put at the back. Okay, for multiplication, you can throw the single digit here behind. 2 times 7 is 14, bring up. 3 times 7 plus 1. 3 times 7 is 21, and plus 1 is 22. So 2, bring up here. 5 times 7 is 35. 35 plus 2, you have a 37. So there you go, 37.24. Make sure the dot is obvious enough, okay? Now the next one, value of 3/10, 25/10, and 400th. Okay, so take note of the difference between these two spellings. One is a tenth, and with an S. The other one is a THS. Okay, so this is how I usually teach students when you have like this, present tense versus tenth. It may get a little confusing. Okay, so I need you to go back to your basics, recall your basics. When I say 3/10, the one with the S, 3/10, okay, most of you can straight tell me, oh, it's 30. But 3/10 also means 3 times 10, if you recall this. Okay, so this is actually 3 times 10. That's how we get a 30. 3 sets of 10. Okay, now 25/10, this will be the opposite. So THS, it will be the opposite of times. If this is times, this of course would be division. So 25 divided by 10. Okay, so 25 divided by 10, all right, this is where, all right, you can put it as a fraction. I think some of you may be comfortable with putting it as a fraction, 25 over 10, or you can use the shifting decimal point method. Okay, so in this case, 25 divided by 10. Some of you maybe want to do long division. Actually, that's all right also. Okay, so 25 divided by 10, how do you shift the decimal point? I'll do my workings here. So decimal point starts from the back. Okay, just always by default starts from the back first. When you divide by 10, you basically move this backwards one space. And the dot ends up here. So this will be a 2.5. Okay, or some of you prefer to see as 25 over 10. No problem. Okay, 25 over 10 means it's a 2.5 with the decimal point, between before the 5. Okay, so take note, 10 means your final answer here must have. Oh, sorry, no, it may not be true. Okay, it may not always have one decimal place. So maybe when we go to P5 and P6, you will see those kind of examples. All right, so yeah, this is how I usually teach the students. Okay, moving the decimal point backwards. If it's a division, you move backward. If it's a multiplication, you move it forward. Erase this. Now the next one is 400. So actually same thing. 400 THS means you take 4 divided by 100. All right, so why am I saying this divide times? Because especially for this, when you have 2 digits here, you have 2 digit 2 and 5 here, it's a bit harder to figure out, which is why I'm teaching this division way. All right, but if it's single digit, actually it's a lot easier. If it's single digit, you will know that, okay, this actually is just 0.04. The 4 basically you just put it in the 100th position, the second decimal point, second decimal place, sorry. Now, what you should do next is you should go on to add all these things. Okay, so 30 plus 2.5 plus 0.04. All right, so if you add them up, now you can do your long working at the side, no problem. Just make sure that the decimal point is aligned together on the side working. That works also. All right. If not, then the quick way is actually you can just observe that the whole plus the whole plus the whole first. You see, I add the whole numbers. Those before the decimal point are the whole numbers. 30 plus 2 plus 0. Okay, so 30 plus 2 plus 0 is actually a 32. Then you put the decimal point. All right, first decimal place, this one no first decimal place, this one is a 5, this one is a 0. So 5 and 0 together is just a 5. Second decimal place, this one no second decimal place, this one also no second decimal place, this one second decimal place is a 4. So it's like this. Okay, so it's 32.54. So if I want to color code, means I look at that. And finally, the last one. Okay. So what I color coded red is the first decimal place, blue is the second decimal place, green is all the sum of the whole numbers. Okay. All right. We are going to go on to the next question. Kelly had a total of 60 pens and pencils. After giving away 3/4 of her pens and 20 pencils, she had an equal number of pens and pencils left. How many pencils are there at first? Okay, for this question, all right, so for this question, it will be best if you use the model method. If you do before change after, it will be tough because I only have total at first. I don't know individually how many pens and pencils are there, all right? And at the end, after the giving away, at the end, I only know equal pens and pencils left. All right. So it's not very helpful to do before change after. Before change after is helpful if let's say you have a fixed value for either pens or pencils at first or in the end. Then okay, if they give you that kind of information, it's fine. So for this case, I think model would be better. So let's say if you have done before change after, you are stuck, it's okay, just change your approach. Okay, just switch your approach to use the model method instead. All right, it happens, it's fine. All right, okay, so when I begin my model, I will start with the 3/4. This will be the best information to start with, right? Because this 3/4 tells me the units for pens at first. After giving away 3/4 of her pens, that means your 4 units is her pens at first. Okay, so I'll start off with pens. I draw 4 units. Pencils. Pencils, I do not know how many units, so never mind, let's leave it alone first. For pens, I think what we should do is we should shade away. Okay, so after giving away 3/4 means I shade this away, 3 units, shade it away. I shade the last 3, not the first 3. The first unit, leave it alone so that we can compare. Okay, and she also gave away 20 pencils. After that, she had an equal number of pens and pencils left. Actually, this equal pens and pencils left will be helpful because this equal pen and pencils left, if you look at pens, can you see your pens left now is this 1 unit left, the unshaded left. So what happens is that you need your pencils left to be the same size, the same 1 unit. So you see, I drop it down like that. All right, so your pencils model, actually at first you don't know how big is it. Just draw some random size, maybe something like that. Make sure the ending line of pencils does not coincide with any of the unit lines because you don't want to accidentally think that pencils like 2 units or pencils like 2 units. It's very confusing, very misleading. Okay, so we avoid that generally. So our pencils, this will be our at first pencils model. Can you see that means the 20 pencils to give away is actually this part. Okay, so basically your pencils to shade away is this part because you want the leftover pencils here to be the same size as the pens here because equal pens and pencils left. So of course, this must mean that this is your 20 pencils. Okay, yeah. So now let's go on to label the 60. Back to this information. She had a total of 60 pens and pencils. This 20 means at first, right? Total 60 altogether is the at first. At first means everything here. Both the shaded and the unshaded is your 60. So 60, you can present it at the side here. Okay, so take note, must bear that in mind, 60 is everything because that is your at first. At first is everything. All right, so now I need you to identify on the model where are your units. Okay, so if you observe, your units is actually this, and this one. So there's 1, 2, 3, 4, 5 units to solve. So we're going to solve for 5 units. So to find 5 units, you should use your 60 minus away the 20. You don't want the 20 because you only want the 5 units. Okay, so of course, now work out 1 unit. 1 unit is just 40 divided by 5. So every unit is 8 items. Okay, so it means this will be an 8 that I just found out. So now read the question. The question is interested in how many pencils at first. Pencils at first means this whole stretch. That's your at first. Okay, so you see a 8, you see a 20. So your pencils at first is actually 8 plus 20. So that's it. This is your answer. Okay, we'll move on to question 11. Complete the figure using the dotted line XY as your line of symmetry. Okay, so this is your line of symmetry. So now left-hand side diagram is shown already. You just need to draw the mirror image on the right-hand side. Okay, so I'm going to start from the top here. All right, so since this one goes down like this, so you do the same here. I don't have a ruler. I can't use a ruler to draw my screen. So students, please use a ruler and a pencil to draw. Do not use pen. Okay, pencil and ruler to draw your line nicely. So don't follow mine. Mine might be a bit crooked. Okay, but I'll do my best. So this will be your first line to draw. Now the next one is this one goes up, right? So of course this one goes up like that, mirror image. Okay. Next is horizontal line. So follow the same. Horizontal, down 2 steps. 1, 2. Okay. Next is go this way. So I'll go down towards the left hand side. It's very hard for me to draw on the screen. Okay, next will be down 2 steps again. So down 1, 2. Okay, next is it goes to the left. So I go to the right. It goes down 1 step, 1 step, goes to the right across two squares. So I do the same. I go to the left 2 squares. Okay. And finally, I go all the way up here. Okay, this is a bit far. Let me try my best. Okay, something like that. Oh, okay, that's nice. Try again. Okay, something like that, yeah. All right, so just hold your paper from far. After you're done, hold your paper from a distance away. See whether it looks okay or not. Okay, if it looks symmetrical, means you are doing it right already. All right, so yeah, this will be your line of symmetry here. Okay, question 12. Paisley had 72 stickers at first. She gave away some of her stickers to her brother and 25 stickers to her sister. She had 3/8 of her stickers left. How many stickers did Paisley give to her brother? Okay, so for this question, all right, there are a few ways to do this. You can actually go on to do like a before change after, or actually if you don't do before change after, it's fine also. I feel okay, maybe actually don't need to do before change after because actually this 3/8 is a very useful information to begin with. All right, she had 3/8 of her stickers left. All right, so that means you can start off with drawing 8 units in the model. Yeah, you can go on to draw a model. Let's draw longer. 8 units is quite a lot to cut. So draw longer so that we have space to write down numbers on it later also. Okay, do not draw too small. If you draw too small, everything is so cramped, it's more difficult for you to write things on your model. Okay, so I have my 8 units now. So out of 8 units, the question says that she had 3/8 of her stickers left. Okay, so I'm going to assign 3 units at the back here. This is her left. Now that must also mean that these stickers here, first 5 units here is what she gave away. She gave to her brother and to her sister also. So this basically is just to brother and sister. So I'll just put row plus sis. Now, Let's look back at the information. Okay, sister is 25. We can put a 25 there. Okay, so these are the things to quickly label down once you know. Now, we remember she has 72 at first, right? So 72 at first on the model basically is the whole thing. Agree with that? So this 72 is the whole stretch. This is what she has at first, like this. Now, can you see now you can easily begin solving because you can easily find out how many units is the 72. All your 8 units is your 72. So there you go. That's your very first starting step with 8 units is 72. Of course, I work out 1 unit. 1 unit is 72 divided by 8. Okay, which is a 9. So every unit is 9. All right. So if you want, you can annotate back into the model. 9 is per unit like that. Okay. So now the question is asking how many stickers did she give to her brother? So brother is here. Okay. But brother now is together with the sister, right? For the model. So what you should do is find out both brother and sister together first. So look at the 5 units here. Look at the 5 units here. So 1, 2, 3, 4, 5 units. So all the 5 units is what she has given away. Okay, so we're going to calculate out this 5 units. Maybe you can put the word gave. So basically it's 9 times 5, which is 45 that she has given away in total to both the brother and the sister. All right. Now, that means to both brother and sister together is 45. Can you see sister is 25? And that means we can easily find out what she has given to her brother. You can just use your 45 that she gave away minus away what she gave to the sister. So that's it. That means she has given 20 stickers to her brother.
Okay, question 13. So Alan had $36.70 at first. He spent $7.65 on a burger and a cup of drink. So his mother gave him $6.50 later that day. How much did he have in the end? Okay, so this question actually is pretty straightforward. It's actually just working forward with the values that are given here. All right, so what he had at first is 36.70 and he spends money on food. So you can actually go on to find out how much he's left with after buying the food. Okay, so after buying food, 36.70, you simply minus $7.65. All right, so let's proceed to do the subtraction together. So 36.70 minus, try to space out the digits as you're doing your workings. Okay. Okay, so let's begin. So 0 minus 6, sorry, 0 minus 5 cannot be subtracted. So 7 cancel becomes 6, and this 0 becomes a 10. Okay, so you can just put a 1 next to the 0 also can. So 10 minus 5 is 5. 6 minus 6 is a 0. Put the dot down. 6 cannot minus 7. Cancel. So really it's just your normal subtraction. This becomes a 16. 16 minus 7 is a 9. And we have a 2. Okay, so it's $29.05. This is after paying for the food. Now, and the thing is, later that day, his mom gave him money. All right, so which means that if his mom gave him money, now his money would increase by 650. So if it's an increase, means from the $29.05, we're going to plus $6.50. Okay, I shall not do the side working for this. I think this is pretty straightforward. Just make sure your decimal point is aligned top and bottom with each other. All right, so this one you should get $35.55. Okay, we shall go on to question 14. All right, so question 14 onwards, the questions are of higher weightage, which means that there are more marks given to each question. Okay, so you should expect a higher level of difficulty for this as well. All right, so let's look at this. The price of muffins at a bakery is shown. So notice that the prices, there are different types. Every muffin you buy is 80 cents. But if you decide to buy if you decide to buy box of 2 muffins, it's 120. Box of 4 muffins is 220, and 6 muffins together is 320. Okay, now so questions like that, all right, there's a reason why they have different prices listed for the different number of muffins that you purchase. All right, simply because the more you buy, especially the box like this, box of 6, the more you buy, the more worth it will be for your muffin. So if you don't believe me, you can do a test to try. One muffin, it's supposed to be 80 cents, right? Let's say you find box of 6 muffins. If I would buy 6 muffins separately using the 80 cents, it's actually 80 cents times 6, which is actually $4.80, right? If I find 6 muffins, it's actually $4.80. But you notice that the price stated here is only $3.20. So they are kind of like giving you a discount. They're giving you a better deal. You buy more from me, I give you a better price. Okay? So this is how it works. So of course, if I were to choose which options give me the most worth is most worth my amount of money, it will be, of course, the last option. If you buy a box of 6, this is the most worth your money. Okay? So Mrs. Tan wants to buy 35 muffins. What is the least amount she needs to pay for the muffins? Now you see, she want to spend the least amount. So if you want to spend the least amount, of course, you would try to choose the muffins that are more worth your money. And which one is more worth your money? Of course, I will prioritize the box of 6 first. So definitely this will be my priority. I will put more importance on this first so that I can spend as little money as possible. Okay, so she wants to buy 35 muffins. All right, but every box only have 6 muffins. So this is where your grouping concept comes in. All right, so I'll prioritize the box of 6 muffins. We are going to find out how many boxes of 6 that I can buy. All right, so let's do just that. Okay, so boxes of 6 muffins would be, you simply use the 35 muffins divided by 6. Okay, so we perform the division like that, 35 divided by 6, because every box has 6 muffins. So I want to find out how many boxes are there to, to be close to like 35 muffins. It may not be an exact multiple, I agree, but, find something that's close. So if you do your times table, if you're good at your times table, you realize that this will be 5, remainder 5. So what does the first 5 represent? Okay, so the first 5 you all must understand is actually the number of boxes, because that's our goal, right? When we do the division, this is to find boxes. Now, and what about this 5 here? All right, so the remainder 5 here is actually remainder 5 muffins. Okay, so how do I know it's muffins? If the first number in the division is muffins, this remainder 5 will also be muffins. So it means that inside 35 muffins, I can buy 5 boxes of them, but I will have a leftover of 5 muffins that I still need to purchase, of course. Okay, so I definitely still need to purchase this. Okay, so now that we realize that there are 5 boxes of 6 muffins, okay, we shift our focus to the money now because the question is asking for money in the end. All right, so we're going to focus on finding out how much do I pay for these 5 boxes first. So let's do that first. So I'm just going to use an orange color pen to settle this. Okay, so let's work on that. Okay, so now one box of 6. When you look at one box, there's so many boxes, right? Don't look at the wrong one. You're looking at boxes of 6 muffins. So the one box of 6 muffins costs you $3.20. So that is the cost of one box. We're going to list out like that. Now, but because I'm paying for 5 boxes, okay, so to find the cost of 5 boxes, $5 times, sorry, 5 times $3.20. All right, so this will give you $16. Okay, now that's not all. Remember, if you buy 5 boxes, it's actually not enough because 5 boxes actually is only 30 muffins. Because 5 box of 6 is 5 times 6, 30 muffins only. Okay, remember she wants to buy 35 muffins. This is where you need to know she needs to buy her remainder of 5 muffins. This 5 muffins confirm she have to buy it. Alright? So this 5 muffins, how to buy? Again, you will focus on the amount of money that is of priority, that holds the most value. Okay, 5 muffins, of course you can't buy this one. Lah. This I put star is for the orange color previously. I want to focus on the 6 boxes of 6. But now, to buy 5 muffins, I cannot use this. So never mind, you use the next best one, which is box of 4 muffins. Alright, so in this case, I'll just split up the 5 muffins. This will be the box of 4 muffins. And if I buy a box of 4 muffins, means here left with 1 muffin that I still need to purchase. Okay, now 1 muffin easy lah. If you look at 1 muffin, it's actually 80 cents. Okay, so no choice, you have to spend the 80 cents, although it doesn't seem so worth it, but you have to buy it then. All right, and then a box of 4 muffins, straight away you can see box of 4 is $2.20. Right? Okay, so there you go. Once you have all the amount of money stated clearly, just go on to add them up. $16 plus the $2.20 plus the last 80 cents. All these three different pricings, but she has to pay for all this. Okay, so this gives us $19. That means she has to pay a total of $19. We shall move on to question 15. Susanna baked some pies. She gave 1/4 of them to her relatives and 1/3 of them to her neighbors. In the end, she had 30 pies left. What fraction was she left with in the end? Okay, so let's focus on the fraction first. So we know that relatives, she gave 1/4. Okay, so we shall just put down relatives. So if you ask me, do I need to draw model for this? You can. Okay, let's say you prefer to draw model for that, no issues. But I would think that actually it's not necessary. I will explain why later. So neighbors, I know she gave 1/3 of them. Okay, so why I say it's not necessary to draw model? Because these two denominators, both denominators represent the same total pies that she baked at first. If you see the sentence structure, she gave 1/4 of them to her relatives. The word of them means the 4 units is the total pies at first. Same over here. She gave 1/3 of them to her neighbors. 1 is to her neighbors, 3 is the total bake that she baked at first. So you can be sure that both denominators, no issues. You can proceed to make them the same. This is 3/12. This is 4/12. Alright, so again, you don't have to draw model from here. If you want to draw, that means you will be drawing 12 units out. Alright, that's fine also, but not necessary. We are interested in fraction left in the end. So left, very straightforward. Remember your starting that you bake is actually 1/2. Then you just need to minus what she gave to her relatives and also minus what she gave to her neighbors. So this will be 5/12. So that's your first answer. This they just asked for fraction, so just leave it like that. Now for B, how many pies did she bake? So now, if you refer back to the question, you notice we have not used the 30. So this 30 is in the end, the leftover. Remember part A, our answer here is also the left in the end, which also means this 5/12 is actually your 30 pies. So we can safely say 5/12 is our 30 pies. Now take note, do not use an equal sign for this. Please use an arrow because if you use equal, you're saying 5/12 equal 30. It sounds numerically it's not right. So you should use arrow to mean represent. 5 units out of 12 units represents 30 pies. Okay? Now, naturally, the next thing is to find 1 unit. So 1 unit means 1 out of 12. Present it this way. So to find 1 unit, you can just use a 30 divided by 5 because this 5 units represents 30 pies. Now we want how many she baked. So remember all together what she baked is 1/2 And one whole, in other words, also means all the 12 units, 12 out of 12. So simply 6 times 12, which gives us 72 pies. So this is your answer. Okay. Okay, this is our last question, question 16. Now, Kim mixed 2.5 liters of water with 0.85 liters of syrup to make a fruit punch. She accidentally spilled 1/5 of her fruit punch. What is the volume of fruit punch left? Okay, so first we need to find out what is the volume of the original fruit punch first. Because for the fruit punch, I only know she used this much to water, this much syrup, she mixed them together. That's how she made the fruit punch. Okay, so the total fruit punch at first, which is 2.5 liters plus the 0.85 liters. Okay, now I'm going to show the side working for this. So 2.5 plus 0.85. Again, make sure the dots are aligned. You see, I put a dot first in case you don't know where to put the dot. The 0.85. So you see, above the 5 is a gap, right? So never mind, I'll just put it with a 0 there. Just replace it with a 0. Okay, so just do the division as per normal. 5 plus 8 is 13. Bring the 1 up. Put the dot down. Okay, so this will be a 3.35 liters. This is the total that she has at first. Now the question says she spilled 1/5 of her fruit punch. All right. So in other words, if I were to present a model for this, okay, so if you ask me, do I need to draw a model? Not compulsory, but to some of you, maybe the model helps you understand what where the 3.55 liters is about. Okay, so out of 5 units, okay, she spilled 1 part. So let's go and put the word spill. All right, and whatever is left, of course, is your last 4 units. Now, what does that mean about 3.35? 3.35, of course, would be your total at first. That is the total fruit punch that she started with. Okay, so I think it's pretty obvious from here already. If you look at the model, you can see that 5 units is actually your 3.35 liters. So of course, I can work out 1 unit. Always want to work out 1 unit as usual. So 3.35 liters divided by 5. Okay, so this works out to be 0.67 liters. All right, so I'll show the long division as to how to get the 0.67. So 3.35 divided by 5. All right, so first step, divide to go up. 3 divided by 5 is 0. Bring down this, multiply. 0 times 5 is 0. So 3.35. All right, so just bring down the next digit, 3.3. Actually, the point, don't write down. So normally the point is only used for putting it up here. Okay, so erase the point just now earlier. The point should be up here. So this is a 33. Just bring down the next digit. So repeat the same 4 steps. 33 divided by 5. You have a 6. 6 times 5 is 30. Bring down the next digit. Repeat again. 35 divided by 5 is 7. 7 times 5 is 35. Okay, and that's how you get a 0.67 liters here. All right, so every unit that's that. Now they want the volume left. Whatever is left, as we can see, it's 4 units. So let's work that out. Which also means 4 times 0.67 units. Okay, I trust that the multiplication you all know how to do. Okay, so I shall not harp on that. So this one should give you a 2.68 liters. All right, so that's your leftover. Okay, she poured the remaining fruit punch into 9 bottles. How many liters was there in each bottle? So this remaining fruit punch, they will be talking about the left lah, right? Because she spilled 1/5 already, then whatever is left is also the remaining that they are referring to. So this remaining of 2.68 liters, she want to split them into 9 bottles. Which also means I can say 9 bottles, total volume is 2.68. Of course, if I want to find 1 bottle, just do the division. Okay, so I'm going to perform the long division here. So 2.68 divided by 9. All right, so step 1, we are going to divide to go up. So 2 divided by 9 is 0. Multiply to come down. Bring down the next digit, it's 26. Dot, bring it up. Okay, bring it up in the same position, right above the previous dot. So 26 divided by 9, repeat step 1. 26 divided by 9, you should have a 2. 2 times 9 is 18. Subtract, bring down. 88 divided by 9, it should be a, like, 9 times 9 is 81. Now you notice I have a remainder up to here, right? Okay, and the question clearly said round your answer to 2 decimal place. Now when they say round, means you need to do the estimation. You need to correct, round up, either round up or round down your answer to 2 decimal place. And for that to happen, it also means your answer here should at least have 3 decimal places. So I cannot stop here yet. Okay, because this only 2 decimal places is not enough for me to perform the rounding. All right, so rounding is not just say, oh, you cut off at 0.29. No, it doesn't work that way. It relies on the 3rd decimal place. It relies on the number next to it on the right-hand side. All right, so you have no choice. You should go on to extend this part. Place a 0 and bring down the 0. So this becomes 70. 70 divided by 9, you should get a 7. 7 times 6, sorry, 7 times 9 is 63. Okay, and in this case, it's okay to stop here already because you already have 3 decimal places. It's enough for you to round to 2 decimal place. So this is actually a 0.297 liters. So now you just need to round off to round off to 2 decimal place. Use the curly equal sign. Okay, so when you do the rounding, make sure you're clear. Look at the second decimal place first because they say 2dp. Neighbor on the right-hand side is a 7. 7 is a strong number. Okay, so 9 will level up. 9 level up, it cannot become 10, right? So it will spill over to the 2. So this becomes 0.3. And you have to put a 0. Okay, you have to do that. Put the 0 behind the 3 because your final answer must appear as 2 decimal place. So if you just put 0.3, okay, technically, numerically, it's not wrong. 0.3 is the same as 0.30. Numerically, both are correct. But because of the decimal place definition shown here, you have no choice. You need to add the 0 behind. All right, so after rounding, this is your volume per bottle. Okay, so I've come to the end of the paper. Thank you so much.